Okay, hi guys. This video is a continuation from the previous video. We will still be talking about the average and marginal cost curves, and we'll be talking about the special cases as well as the dynamics of how these curves are going to move. So let's begin with the special cases. The first special case would be the case where there is decreasing returns to scale, increasing returns to scale, as well as constant returns to scale throughout the firm's level of production. Okay, so what we need to do is we need to derive the LRAC, the LRMC, SRAC, and of course the SRMC. Okay, so just a bit of recap. When we talk about returns to scale, we are talking about the long run. Okay, it's not a short run, it is a long run. So we know that when it's decreasing returns to scale, your RLTC is going to look like this. When it's increasing returns to scale, your LRTC is going to look like that. And when there's constant returns to scale, the long run total cost is simply a straight line. So what we're going to do is we're going to add in our short run total cost curves to these three different graphs over here. And from there, we're going to derive the different average cost as well as the marginal cost. So let's begin with the case where there is decreasing returns to scale throughout. Okay, I'm going to need two sets of axes, as you can see over here. So a firm that is experiencing decreasing returns to scale throughout will have a long run total cost that looks like that. Okay, now I'm just going to add in my short run total cost and make it intersect somewhere with the long run total cost curve. And now I'm going to start to derive the average cost curves. So recalling from the previous video, the first step would be to determine where your LRAC is first. And of course the first step is to find out where is the minimum AC. And you will notice that the minimum AC is actually where the origin is, because as you can see from my ruler, that is the flattest point that my ray can go. Okay, so the minimum AC is at the origin itself. So let's talk about the shape of the LRAC instead. And to identify the shape, let me just break it down into two parts. I'm going to draw one ray here and another ray there. So what you will notice is that your average cost is actually increasing as the quantity of X increases, and that is because your ray keeps getting steeper and steeper as you progress along the horizontal axis, and that is why your average cost curve for the long run is going to look exactly like this. So the next thing we're going to do is to find out the LRMC. So we know that LRMC is going to intersect where the minimum average cost is, but in this case, the minimum is simply near the origin, somewhere there. Okay, because that's the lowest point, that's the lowest ray. So let's talk about the shape. And I'm going to be drawing tangents at these points where the ray is. And I'm going to notice that the marginal cost is going to increase as my production of X increases. And this is because the tangent gets steeper and steeper as I move along the horizontal axis. So what I can also see is that the tangent will always be steeper than the ray. Okay, you can try this out by yourself. Therefore, your marginal cost is going to be more than your average cost, and that is why your LRMC will always be above your LRAC. So you see, that's pretty straightforward, right? Now the third thing I'm going to do is to define where my SRAC is. To draw the SRAC, you are going to need 2 points. Recall from the previous video that the first point is the point where the SRAC meets the LRAC. Okay, and that is also the point where my SRTC equals to my LRTC. And that point just happens to be somewhere around here. So what I'm going to do is I'm going to extend the vertical line downwards. And I'm going to mark out this point because that's the point where the LRAC will meet the SRAC. So of course, second thing I'm going to do is to find out where's my minimum average cost for the short run. So find the lowest ray, just like this. So drawing the vertical line down, I'm going to mark the minimum AC, which is somewhere here. Now, why is it here? It's here for two very simple reasons. Firstly, because it has to be more than the LRAC, and it has to be less than this point over here. Alright, if not, it's not much of a minimum, right? So I got 2 points. I'm just going to connect these two lines together in a U shape, and I have my short run average cost. Okay? So now we're on to the last curve, which is my short run marginal cost curve. So the short run marginal cost curve is going to intersect the minimum AC just over there. And you also need another point of intersection. And the other point of intersection is the SRMC will meet the LRMC. And it is at a point where both total cost curves meet. So it is this point over here, that red dot. And once I got these two dots, I can just simply join up the two dots together in an upward sloping curve. and that actually gives me my short run marginal cost curve. Okay, so that is how you derive these curves. You will actually notice that you are drawing the short run curves that are in blue. Okay, so you're actually drawing SRAC2 and SRMC2. Alright, so if you're just gonna take a ruler and you're gonna cover the left hand side of the minimum LRAC, it is exactly the same thing that you see over here. Okay, I know that that was fast, but we're going to do it fast because we really got a lot of things to cover for today. I'm just going to go through the other two types of scenarios so that we got more practice. Okay, so the next thing that we're going to do is we're going to derive the curves for the case where a firm is going through increasing returns to scale throughout. So the total cost curve is going to look like that. Okay, that's the total cost for the long run. And I'm going to add in my short run total cost curve. Okay, and the short run total cost curve will definitely meet the long run total cost curve at one particular point. So the first step again is to look for my long run average cost curve. You will notice that there is actually no minimum average cost curve because the ray just keeps going and going and going. So let's talk about the shape of the LRAC. Okay, let's draw vertical lines to separate this long run total cost curve so that we can draw the rays to them. And you'll notice that your average cost is actually decreasing as x increases because the ray simply gets flatter and flatter as you move along the horizontal axis. Okay, so that is why your long run average cost curve is going to look like this. It is decreasing. Now, secondly, let's talk about the long run marginal cost curve. Now, the first thing to do is to talk about the shape, right? There's no point talking about a minimum AC because it doesn't have one. So I just drew the tangents, and you'll notice that the marginal cost is decreasing as x increases because the tangent, again, keeps getting flatter and flatter. Okay, so why don't you try this by yourself? Which curve will be on top and which curve will be below? Okay, will the AC be below of the MC or will it be the other way around? To answer this, you're going to have to compare the rays and the tangents, right? Just like how we did previously. So you will notice that the rays are always steeper than the tangents. Okay? And because the rays are always steeper than the tangent, your AC is always going to be more than your MC. So that is why your LRMC will be drawn below your LRAC. Okay, so now that you've got a long run curve settled, let's go to the short run curves. Okay, and we'll begin with the I should be using green. We'll be starting with the short run average cost curve. So the first point intersection will be with the LRAC, and this occurs when both total costs meet each other. It will be this point, and I'm going to draw a vertical line down, find the intersection, and the next step will be to identify the minimum AC for the short run. Find the lowest ray, which is somewhere there. Draw the vertical line down, and put this point here. Okay, now this point will always be bigger than the LRAC, which is higher, and it's always going to be lesser than this particular point because it is the minimum AC. So now I've got 2 points. What I'm going to do is I'm going to carefully join these two dots together in a U shape, okay, so that would form my average cost curve. Right, just add in some of the finishing touches and we'll label that as the short run average cost curve. Okay, the last one, your short run marginal cost curve. So the short run marginal cost curve, as you know, will intersect with the minimum average cost in the short run. So that is one intersection point that I found. So time to look for the second one. The second intersection is where it meets the long run marginal cost. And again, this is the point where the both total cost curve meet each other, which is over here. So draw the vertical line down, mark that point where both curves are going to meet. Then just use a finishing move of connecting the dots and you have your short run marginal cost curve. See, it's that easy. So I'm going to bring back the graphs from the previous video, and you'll notice they're actually drawing the green short run curves that you see over here. And it is actually just on the left side of the ruler, and I'm actually putting the ruler at where my minimum average cost for the long run is. So if you know how to draw all those three graphs, then you will have no problem drawing the graphs for the case of decreasing, increasing returns to scale throughout the firm's production quantity. Okay, awesome. Now let's move on to the last scenario where there is constant returns to scale throughout. So first, same thing, I'm going to draw my two sets of axes. And the long run total cost curve is going to look like this because of constant returns to scale throughout. Now, same thing, I'm going to add in my short run total cost curve, which is going to meet the long run total cost curves somewhere. Okay, so that's my SRTC. Now, the first thing that I'm going to do is I'm going to look for my long run average cost. Again, there is no minimum LRAC, so let's talk about the shape. You will notice that you won't be able to draw any rays to touch this LRTC because the LRTC is actually the ray itself. So the ray doesn't change throughout the entire cost of production, which means that your average cost will remain the same as the quantity of X increases. And this simply means that your long run average cost curve is going to be a horizontal line across this graph over here. Okay, so in blue, this will be my long run average cost. Looks very simple, right? So you're going to notice that this is not equal to 0 because your ray still has a more than 0 gradient. Okay, it's a positive gradient because it is upward sloping, right? So it is not 0. The LRAC is still more than 0. So the next thing we're going to talk about is the long run marginal cost curve. Let's talk about the shape of this. You will notice that the tangent also has got no change because the LRTC is the tangent itself. Therefore, the marginal cost is the same throughout the production of X. Okay, so it doesn't matter how much X you produce, your marginal cost is the same. When you have a constant marginal cost, what that means that the curve is actually a horizontal line. It is also very easy to see that your tangent is actually your ray. Therefore, your average cost is also your marginal cost. And that means your long run average cost is your long run marginal cost. Okay, that was easy. Let's try drawing the short run average cost curve. Now the first intersection point will be of course with the LRAC, and this is the point where both total cost curves meet. And that point is just over here. Okay, so I'm going to draw a vertical line down. This is where the SRAC is going to have a intersection point. And of course we need to find where the minimum AC is. Well, after you have tried, you will realize that your LRTC is also the lowest ray to touch the short run total cost curve. Therefore, this point over here is also the minimum AC. So that makes our life easy. We just have to draw a U-shaped curve over here, and that will be your SRAC. Well, I don't think I really need to explain much about drawing the SRMC because I think it should be pretty straightforward from now on. He just has to cut through the minimum average cost curve, and he has to cut through the LRMC where the both total costs meet, which is also over here. So simply just draw the MC curve in, and there you have it. Okay, so that's the SRMC. Congratulations, you've completed the first special case. Okay, and notice that you're actually drawing the red short run marginal cost and short run average cost curves that you see in this graph from the previous video. Well, the only difference is that your long run average cost curve and your long run marginal cost curve is simply a flat line right now. Okay, so the next special case that we'll be talking about is the case whereby a firm faces constant marginal cost. Now, you've seen a smaller example of what constant marginal cost look like, but right now we're talking about analyzing firm behavior. Okay, and when we analyze firm behavior, we're actually more interested in what the firm is going through in the short run. Okay, because in the short run, the firm can take certain immediate actions according to whatsoever economic disturbances that the firm faces. So this is going to be key for chapter 4, which is on market structures, and that will be the next chapter after this video. So your job is to simply derive the average cost curve when there is constant marginal cost in the short run. Okay, so this is not going to be very straightforward. You actually need to learn how to work backwards in deriving your average cost curve. So what I mean by working backwards is simply this. You used to derive the marginal cost curve from the total cost curve, right? And from the total cost curve, you will also derive your average cost curve. What you actually need to do is to use the marginal cost curve to derive the total cost curve, and then you use that total cost curve to derive your average cost curve. So that is what I meant by working backwards. We're going to make the assumption that marginal cost is constant at the value of C. Let's go to the graphs and understand how we can work backwards to derive the average cost curve. Okay, it's not going to be a regular U-shaped average cost curve as you will see in a little while. So when a marginal cost is constant, you actually see a straight line, a horizontal line for the marginal cost at the level of C. Just let me share with you my thought process on how this is going to be done. We can ask ourselves, how do you find the average cost curve? What does the total cost curve look like when the marginal cost is constant as a horizontal line like this? So your marginal cost is going to be constant, okay? And that means that your tangents or your tangent's gradient is going to be the same throughout as x increases. Okay, there'll be no change in tangent. Therefore, your total cost curve is also a straight line and it is upward sloping. It is upward sloping because of a positive marginal cost. Okay, a positive marginal cost basically means that the gradient of the total cost curve is positive. And a positive gradient means that the tangent is not a horizontal line. It is a upward sloping line. Therefore, your short run total cost will look something like this. Make sure you include the fixed cost in, and the gradient of this total cost curve is going to be C. Now all you got to do is to use this short run total cost curve and derive your average cost curve. See, it's quite easy, right? So I'm going to break the total cost curve into several portions, and I'm going to start drawing my rays to them. And what you'll notice is that these rays keep getting flatter and flatter. And what does that mean? It means that your average cost is decreasing as x increases. So your average cost curve will look something like this. Okay? Now, the question you need to ask is, will the two curves meet as x keeps increasing? Well, the answer is no. Why? Well, that's because the tangent and the rays, they will never be parallel to each other. Okay, so once they're never parallel means that their gradients are never going to be the same, so they are not going to meet. The AC and MC will not meet. So that sums up the second special case. Let's talk about the third special case, which is the case of a kinked marginal cost curve. So a case where the marginal cost curve can be kinked is, firstly, there's been some investment that has been made on the firm's part. So an example of this investment might be investment in machinery or equipment that can actually increase the production levels. And let's also assume that after making this investment, there is a decrease in the marginal cost after a certain quantity of x. Let's say it is x bar. So after x bar, the marginal cost is going to fall. Now, when you invest, there's obviously going to be an increase in fixed cost in the short run. Okay? And we're also going to assume that the marginal cost is going to be constant before and after the investment is made. So with all these assumptions, what we need to do is to actually derive the average cost curve. And again, to derive the average cost curve, you're going to have to work backwards. It's going to be like how we derive the AC for the constant marginal cost. So let's take a look at the graph. Let's mark out point x bar first. So let's say it is somewhere here. And I'm just going to draw the vertical line down so I know when the cost curves are going to change. So the first marginal cost is going to be here. So let's just call that C0. And we know that after the production of x bar, the marginal cost is going to fall to a level of maybe C1. Okay, and that is due to the investment of the new equipment. So you've seen before this that the total cost curve will look something like this. It is an upward sloping line. So after x bar, what do you think the total cost curve is going to look like? Okay, so you know that this is a lower MC, which means that you have a flatter tangent, therefore a flatter total cost curve. So if that's the case, does it mean that my total cost curve will continue to look like this? Well, the answer is no. Okay, there's one thing that we forgot. We actually forgot the fixed cost. So you actually have to jump up, and that will be your short-run total cost. Okay, the increment, that jump, is actually the increase in fixed cost. So the average cost curve for the blue region is as such. So what do you think the red region will look like? Is it like this? No, it is wrong. Okay, it is wrong because of the following reason. So if you were to draw a ray up to that point of x bar, and you draw a ray to the red portion, you will notice that you actually get a steeper ray, which means a higher AC. Therefore, your average cost curve would have jumped. So I now need to know the shape of the average cost curve. Drawing another ray to the end of the red portion shows that the ray keeps getting flatter and flatter. Therefore, what you will see is an average cost curve that looks like this. So you have already derived the AC curve. When production is before x bar, the blue curves will be in play, and for production after x bar, the red curves will be in play. So the average cost curve in all is that green lines that you see over here. Okay, so we have come to the end of the special cases. I think all these special cases are really good practices for you, and this strengthens your ability to derive cost curves when they throw different kinds of scenarios to you. Now, let's talk about the more important thing, which is the dynamics. How do these curves move? Okay, so we're gonna talk about the difference between the fixed cost as well as your variable cost. Let's begin with the fixed cost, shall we? Now, examples of fixed costs would be things like lump sum taxes or subsidies. Okay, it could also be maybe machinery and equipment cost, right? The cost of investing in these things and selling these things. It can also be the maintenance cost of your machinery and equipment. It can also be interest rates. Okay, now interest rates is a little bit more is a little bit special. It affects only a short-run cost, and more specifically, I'm talking about the short-run fixed cost. It won't be a fixed cost in the long run because capital can change in the long run, right? Capital becomes flexible. So interest rates are actually a form of opportunity cost of capital changes, right? When you sell, when interest rates increase or decrease, it affects the amount of opportunity cost that you have on your capital. So this is not applied in the long run, again, because fixed cost becomes a variable cost in the long run. So you'll notice that your fixed costs are actually costs that have got nothing to do with the amount of production. So it has nothing to do with the production level of the firm. Moving on to the variable costs, some examples could be maybe like your wages. And wages is a variable cost because when you are going to increase your production of X, you need to increase the amount of labor that you employ. Material cost is also an example of variable cost, and of course due to the same reason, when you increase the production of X, you're going to need more material. And another example would be per unit tax. Okay, and per unit tax or subsidy, this is a variable cost because as you increase the production of X, you incur more costs, and of course this works the other way around as well. But this actually behaves very differently from the rest of the other variable costs that you have seen here. It behaves differently from material costs as well as wages. Let me just very briefly explain why. Now, take for example, if I want to increase my labor or increase my materials, what happens is that I'm actually achieving some economies of scale. Not return to scale, it's economies of scale. Why? Because as I increase my labor and these workers work more, they become smarter and they become more productive. So for an increment in the amount of labor, I can actually have a larger increase in the amount of goods produced. So when you work backwards, when I have got lesser labor, so basically I might have some form of diseconomies of scale because with lesser people, I'll be incurring a larger decrease in the amount of goods I can produce. And as I increase my materials, I might have less wastage or I might get bulk discounts. That's why I become more productive. Okay, so the thing is that for the per unit tax or subsidy, taxes in general, it is assumed to be a fixed amount per unit regardless of the quantity that I produce. There is no such thing of the tax rate decreasing as I produce more. There's no such thing as a tax rate increasing when I produce lesser. So there is no economies of scale achieved when there is a per unit tax or subsidy. So that is why this per unit tax or subsidy behaves differently, and it is actually pretty important. So we'll go through that into detail later. Okay, now we talk about how the average cost and the marginal cost is affected when there is a change in either the fixed cost or variable cost. Now, we have to understand this by looking at the total cost formula. And the total cost formula is actually pretty simple. This is the formula. The total cost is equals to the total variable cost plus the total fixed cost. And I can also write it in a way which is the total quantity multiplied by the variable cost per unit plus the total fixed cost. Okay, so by understanding this total cost function, we'll be able to identify how the different curves are affected. So to find the marginal cost, I have to differentiate the total cost with respect to x, and I will get VC, variable cost. You're left with only VC because X has a power of 1 and the total fixed cost is actually a constant figure. So if you differentiate that, you're going to get 0. Therefore, your variable cost affects your marginal cost, as you can see from this result over here. Now, to find the average cost, I need to take the total cost divided by X, and I'm going to get the variable cost plus the average fixed cost. Since you see variable cost and fixed cost as part of the function for average cost, this basically means that your variable cost and your fixed cost is going to affect your average cost curve. Okay, so these are the two key results that we have found, and I can actually phrase this in another way. Okay, I can also say that a change in variable cost is going to affect your marginal cost as well as your average cost. That's because VC affects MC and VC affects AC. See, it's simple, right? And a change in fixed cost is going to affect only the average cost. And how do I know that? Well, that's because fixed cost affects average cost. See, it is very easy, right? And what you're going to do is to download this into your brain. Now, in order to download this into your brain, you're going to need to remember and understand how I arrived at this conclusion. Okay, so rewind the video if you need to understand how I got a conclusion, and this will really help you to download this into your brain. Now, let's talk about a change in fixed cost, which obviously only happens in the short run because costs are only fixed in the short run. So we know that only your average cost curve is going to move, okay, and your MC doesn't change. Now, let's think about it. Why is it that your MC doesn't change? Well, that's because when there is no variable cost change, okay, this means that the slope of the total cost curve has got no change as well. And when the slope of the total cost curve has got no change, what this means is that the gradient of the total cost curve is the same. And that also means the tangent is the same. So when the tangent is the same, you should come to the conclusion that your marginal cost is the same. Therefore, marginal cost, there's no change. Okay? So let's look at how the average cost curve is going to shift. So your average cost curve is going to be shifting up and down in the vertical fashion. And as discussed, it's vertical because the gradient of the total cost curve has no change. Let's look at an increase in the fixed cost. And what you'll notice is that the average cost curve is going to shift upwards. Okay? Now, let me show you this in the graph. Okay, so drawing the two axes, I have my initial average cost as well as my initial marginal cost. So the average cost curve is going to shift up to look like this, the red average cost curve. And you'll notice that the gap between AC1 and AC0 actually gets smaller. Okay? So you're going to notice that the gap becomes smaller as we progress through producing more X, and the reason is simple, and that's because the additional fixed cost gets spread across the quantities of X. Okay, so when you produce more X, basically the average cost is going to fall. Now let me show you this mathematically to explain that little gap over there. So average cost is equals to my total cost divided by X. If my X is going to increase, my AC obviously is going to decrease because of a bigger denominator. And since we're interested in looking at the quantity of X changing, let's look at the rate of change, which means that the change in the average cost is equals to the change in the total cost minus the change in X. So it is easy to see that when the change in X increases, the change in average cost is going to decrease, and that is why there is a smaller gap. Now let's apply this to a decrease in fixed costs. You're going to notice the opposite. So the average cost curve now is going to shift down. And obviously the same thing, your gap is also going to become smaller as you progress along producing more X. And the reason and the intuition behind this is because whatever savings that you have from the decrease in fixed costs is spread across the production of X. Okay, it's the same concept as we just saw in the mathematical approach that you see. Okay, so let's take a look at the graph. So this is my initial AC and my initial MC. My AC curve is going to shift downwards over to this blue line over here, and that's AC1. And you'll notice that the gap starts to get smaller and smaller and smaller. Okay, so the decrease in an increase in fixed cost is pretty straightforward. It's just a shifting of the AC curve. Now let's talk about something that tends to be a little bit more challenging and a little bit more tough for people to understand, which is a change in variable cost. You know that both the average cost and the marginal cost is going to shift due to a change in the variable cost. Okay, now Quickienomics is going to make this very simple for you. Okay, you're going to have to focus on simply the minimum average cost curve. Okay, it's just so simple. Just focus on one thing, because the minimum average cost serves as an anchor for your AC as well as your MC. Okay, so let's look at the total cost dynamics when there is a change in variable cost. We've learned in the previous videos that when there's an increase in fixed cost, what you will get is a steeper total cost curve, right? And what you need to do after your total cost curve has become steeper is to simply find the new minimum average cost. Since we're talking about the total cost curves along with our marginal cost curves, we're going to need two sets of axes. So I'm just going to identify my initial minimum AC, okay, which is along this quantity of x. Okay, so that's going to be my AC naught, and here is my MC naught. So an increase in the variable cost is going to make my SRTC steeper, and all I got to do now is to find the new minimum AC, which is somewhere here. Okay, this level of x where my minimum AC is going to be. So my new minimum AC is obviously going to be more than my old minimum AC, so I'm just going to draw it somewhere here. Make sure the AC curves do not intersect one another. And you know that the MC curve is going to have to strike through that minimum AC. And there you have it. So that's your MC1. Now can you see why the minimum AC is actually an anchor for both your average cost as well as your marginal cost? So what you notice is that the minimum AC is going to move up and then left. Okay, so it's up and left due to an increase in the variable cost. Let me provide with my interpretation or my intuition on why this has happened. So imagine if I produce the same quantity of X, an increase in variable cost basically means that yes, my cost is increased. So that is why I'm moving vertically upwards the vertical axis, because the vertical axis is actually the amount of cost. That's why it's an upward shift. Now the leftward shift of the minimum AC is due to a decrease in the economies of scale that the firm is achieving. And that is of course due to the increase in the variable cost, so they will tend to produce a bit lesser. Okay, so lesser production means that there is lesser economies of scale. Okay, so now that we've got the increase in variable cost settled, let's talk about the decrease in variable cost. Now, if you've understood the increase, I don't think this will be an issue to you. So you know that the TC curve will now become flatter due to a lower variable cost. So what you need to do now is again find the new minimum AC for a flatter total cost curve. Okay, so let's draw the two sets of axes, and so that will be for me to show you the example, show you how this is in action. Okay, so I've got my total cost curve that looks like this initially, and then I'm going to find my initial minimum AC. It is at this level of X, and I'm just going to draw an AC curve that looks something like that. So there's AC naught, and then you've got MC naught. So there's going to be a decrease in variable cost. What that means is that the short run total cost curve is going to be flatter, of course pivoting along the fixed cost. And now I'm going to find my new minimum AC, and you'll notice it'll be towards the right side, and of course the new minimum AC has to be lower than the old minimum AC, right? There is a reduction in cost. Okay, so the AC curve shifts down, and there you have your MC1, and again you're going to notice that the minimum AC moves down and then right. Okay, so let me again give you the intuition behind this. It moves down, okay, because of the cost decrease, obviously, and it moves to the right because there's an increase in the economies of scale for the same amount of X that they produce, so they will must as well just produce more, and that's why the minimum AC moves to the right side. Okay, now let's talk about the interesting thing, which is the per unit tax or subsidy. Okay, as mentioned previously, the per unit tax or subsidy is a variable cost, but it behaves very, very differently from what we've discussed previously. Alright? So, and this is due to the fact that we assume that this per unit tax or subsidy is a fixed amount per unit, regardless of the quantity that you produce or sell. Therefore, there is not going to be any economies of scale for an increase or decrease in the tax rate or subsidy rate. And what you will notice is your minimum average cost actually moves in the vertical fashion instead of diagonally. Alright, what you saw previously was diagonally. Now the AC curve is going to move vertically when there's a per unit tax or subsidy. Let's look at the case where a firm is taxed by an amount of T per unit for producing and selling their goods. So the minimum AC is going to move up by T, okay? And then you have your new AC curve, and your new AC is going to move up in a parallel fashion. So the gap between the new AC and the old AC is going to be T constantly throughout the production of X. There will be no reduction of the gap between the two curves. So the MC is just going to follow, cut through the minimum AC, and there you have MC1. So that's the case for a per unit tax, okay? Per unit tax is imposed on the firm. Now let's look at the flip side, where the firm actually gets a per unit subsidy, okay? And the per unit subsidy is going to take the value of S, okay? So per unit subsidy and subsidy is S. So vertically, the minimum AC is going to move down by the amount of S, and again, I'm going to just draw the new AC curve, and the gap between the new AC and the old AC will be S. And my MC curve is going to follow, and then I've got MC1, and I've just successfully drawn the case whereby there is a per unit subsidy. So you see, it's actually easier than the change in variable cost, right? Because it's just a vertical shift. Now, let me provide you with a mathematical approach on why it is a vertical shift. It is meant to further convince you. You don't have to produce this in an exam. Just make sure that you show the gap between the new AC and the MC that takes the value of either the subsidy or the tax. So here's the math. Imagine that the total cost takes a function of a times x squared plus bx plus c. So this is a total variable cost, and c is your fixed cost. Now, how do I find my average cost? I just divide the entire thing by x, and we're going to get ax plus b plus c over x. Now, to find the minimum AC, I need to differentiate the AC function with respect to x, equate that to 0, and then solve for x to find the exact quantity of x where your average cost is minimum. So that particular quantity is going to be the root of A divided by C. Okay, so we've got this result. Let's add a per unit tax to the total cost function and see what we get for the minimum AC. So the total cost curve, your total cost function is going to simply have T times X at the back. So I'm going to find average cost again by dividing the entire total cost function by X, differentiate it with respect to X, and we're going to get this, A minus C times X to the power of negative 2. Solve for X, and you're going to realize that the quantity of X where your average cost is minimized is going to be the same as previously. It is still the root of A over C. So looking at this at a graphical manner, if let's say this area here is root of A over C, and the average cost curve, let's say, is shifting upwards, that minimum cost is still at root of A over C. So this is a very simple mathematical proof to why there is a vertical upward and downward shift when there is a per unit tax or subsidy. Okay, so this has been a pretty long video. It's been about 40 minutes. I think it's been pretty tiring, but you learn quite a lot of advanced stuff over here. So with that, I would like to sincerely thank you for studying with Quickienomics. I'm going to see you in chapter 4, the market structures.